angle on this side. So we don't need this part of the angle. So we're gonna subtract that part and we're gonna just be left over with this part, which we do need on the right side. So we need to subtract 105.37 minus 90. That's gonna leave us with 15.37. So our bearing from due north is 15.37, or you can write it as north 15.37 degrees east. So either of these two answers will work. Okay, that's number 8, and now let's move on to number 9. So problem number 9. This problem uses law of cosines. This problem is talking about a tower that's on a slope. So we're gonna draw a slope. We're gonna draw a tower. I'm gonna draw a very simple tower just because I want us to be able to see the triangle that is formed. It says that from the tower you have two guide towers. So two guide wires, and they are used to hold the tower, and they're each gonna be 75 feet from the base of the tower. So this one is 75 feet. 75 feet. The distance from here to here is 75. And the distance from here to here is 75 as well. Okay. So they're telling you that the tower is 100 feet high. So it's 100 feet high. They want us to figure out what the length of the guide towers is for each one. Now notice here that you might be thinking that the length of each guide tower is going to be the same, but they're actually going to be different because you're going to have an angle right here that's going to be different than this angle. So that's going to give you different lengths for the guide towers. And the reason is because we're going to be using the law of cosines. So notice right here that we have a side and another side of this triangle on the left, and there's an angle in between. Over here on the right we have a triangle with two sides and an angle in between. So we're going to be able to use the law of cosines. However, the two angles are going to be different, and you'll see how. So here they tell us that the slope creates an angle that's 6 degrees to the horizontal. So the slope is 6 degrees to the horizontal. And if we notice over here, if we construct a horizontal up here as well, then we can see that this angle right here is also going to be 6 degrees. So this angle, 6 degrees, plus this angle should make 90 degrees because this tower is perpendicular to the horizontal. So that means that if this angle right here is 6 degrees, then the angle inside the triangle right here is going to be 84. So this should be 84. And now that we know that this one's 84, then we can figure out this one, because these two angles right here inside the triangles form a straight angle. And we know that a straight angle equals 180. So then we need to just figure out what's the rest. So in order to become 180, this one has to be 96. So this angle is 96 degrees. And now we have the two angles that we needed. So here you can see that because we have two different angles, we're going to get two different answers for the length of these wires. All right. So let's go ahead and label these. Now the labeling is not such a big deal. We just needed to be able to plug in the information into our equations accurately. So I mean, we can use A equals B squared plus c squared minus 2ac cosine of b. So let's say that we have, this is going to be our angle A. So this has to be, I'm sorry, our side A. So this angle has to be A over here. This angle 96. So we're going to label this as A. Can't see it, but just know that this angle 96 degrees is angle A. And let's say this is B. And this is C. Okay? So that means that this 100 meters is lowercase b and 75 represents lowercase c. All right, and now we know which ones to plug in. So A is the one we're trying to figure out. B is 100. C is 75. And then we're going to plug in 100 and also 75. Cosine of B, we said, oops, it should actually be cosine of A. I just wrote the information on here. Cosine of A, so we have A squared. Let me just make sure, sorry, A squared equals B squared plus C squared minus 2 BC. Okay, sorry, this should be BC. Cosine of A, there you go. So I had small mix up on the letters, but everything checks out now. So we have cosine of A, which is 96 degrees. Okay, and now if we calculate everything out, we should get A squared equals, let's see what we get. So we get 100 squared plus 75 squared, that's equal to 15 minus cosine (96) and square root. Okay, so for this one we get 17,192.93, and this is going to be feet squared. And now we just need to take the square root of both sides. So when we do that, we end up getting 131.12 feet. So that's the length of this guy wire on the left side. Now we need to find the one on the right side. So for this one, it's going to be very similar. Let's say that this one, instead of A, you know what, we can also call it A, even though it's going to be two different answers. Or you can call it A prime. Let's say A prime. So this angle down here is going to be A prime, and this is going to be lowercase a prime. And we can still use B, and we can still use this one as C, or C prime. And this one, let's make it B prime. But you can see that even if we label them as with the same letters, same idea here. So we're going to write A squared. I'm not going to write the prime, just so that there's no confusion, equals B squared plus C squared minus 2BC cosine of A. So if you think about it, if we had prime, 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 those are all primes. So then A squared equals, B is going to be 100 still, C is still going to be 75, minus 2, 100, C is 75, cosine of, now this is where it changes. The only difference in this setup right here is that your cosine is now going to be 84 degrees, because now we're looking at this triangle on the right. So that's where this problem is going to change. So cosine of 84. So once we calculate this out, we end up getting, let me go ahead and calculate this out again.